So now I'm asking Nikita on stage. You also can share your screen now for the presentation, and I'm happy to hear your introduction.
Thanks a lot, Pierre, for the introduction. Just give me a second and I'm sharing my screen now. So I think all of you should be able to see my screen now. Very glad to be here and talk to you today about the role of cities in the energy transition and an introduction to the smart cities and the PEDs concept, as Anne and Pierre mentioned. It was interesting to hear your ideas and views on what are the important enablers when it comes to EU's goal to be climate neutral in 2050. I don't know how many of you are aware about it, but today is a very special day to discuss this, as yesterday the EU, different parliamentary bodies within the EU agreed, they came to an agreement to have a provisional agreement at this stage, but still an agreement to make this commitment into a law. So there will be this climate law in the EU where these targets to be climate neutral by 2050 and to have a 55% reduction in carbon emissions as compared to the 1990 levels by 2030 becomes mandatory and obligatory for each of the member states within the EU and the EU as a whole. So a very important day to be here and to discuss how exactly this is going to happen. And today we are going to talk about cities. So maybe let's take a step back and think about what are cities and why would they play such an important role? So feel free to use the chat right at this point too. But what do you think are cities? What characterizes an urban area and how it is differentiated from different kinds of other regions in a country? So from regional regions or rural areas and so on. And the main element that characterizes cities is the density, the large and dense human settlements that come together in a city. And while during a pandemic going on for the last year, we would question whether that density is clearly beneficial, there are very strong benefits for having that density. And I'm going to highlight three, but there are several other there. And first being, it improves efficiency. It aggregates the demand for services in a particular area. So when you think about it, providing mobility, public transport in rural areas is much more expensive as compared to in a densely packed city where each stop and each bus or metro service could be used by many different citizens. Also, think about postal services or any other kind of energy services, water services, and so on. The density improves efficiency. It also reduces cost, therefore, to provide these services. The second important aspect of cities is that it fosters collaboration and innovation. When you have a group of people together, and there's actual research showing that the density has an impact on the number of patents being published by a city. So it has a real impact on how many people collaborate and innovate in an area, which is an important need when it comes to the ambitious targets that we have set. And the third important, and I think most of us are aware about it, is that cities are the economic drivers. It's where a lot of economic activity is happening. It's where companies are born and grow and where a lot of production is happening. So why do they then play such an important role in the sustainable transition and the ambitious targets set out by most of the countries now? They cover around 2 to 3% of the Earth's surface, so a really small percentage, but they account for more than half the population, which is expected to continue rising. They are responsible for 80% of the GDP, and they consume 2/3 of the global energy being produced. Most of you might be aware of these numbers, but it's important to reflect on the key role that cities will play in this transition. Just to put this into perspective, these 100 dots, so this was research done by NTNU, these 100 tiny dots across the globe that you see account for 18% of the global carbon footprint. And in most countries, the three largest urban areas drive more than 1/4 of the national emissions. So you can see that cities are the areas, may it be EU's climate targets, may it be the different, all the other countries that are setting this very similar climate targets. Cities are the areas where we need, which is sort of an opportunity. It's the challenge area, but it's also the opportunity where you can concentrate a lot of these efforts and really get those impacts that can help us achieve those ambitious goals. Cities themselves also have a motivation to work on these challenges because climate change is heavily affecting cities. Floods, urban heat island effects, air pollution, all of these are having vast consequences, major consequences on the cities and their citizens. And especially with the condensed areas, it has many drastic challenges that cities face and are trying to handle day to day. So they are on board in this transition. And you can see that by looking at the commitments that the cities are making, as Pierre highlighted a bit earlier too. There are more than 100 cities who committed to net zero carbon emissions by 2050 at the UN Climate Summit in 2019. Also, EU plans to have 100 climate neutral cities by 2030, which is part of one of the commitments that came from the European Green Deal. So you can see the ambitious targets that cities are having to really tackle and play an influential role in this energy transition. When you look at where this energy comes from, you can see that this is one of the graphics produced by the International Energy Agency. So it's on a global level. Of course, from each city to city, the figures might vary a lot, but you can see that buildings, mobility, industry, and power generation and heat play a major role when it comes to energy consumption within urban areas. And when you associate the power and heat to the actual end use where it is being used, you can see buildings and industry play major roles in urban environments. Mobility also plays a role, and while in comparison to buildings and industry, it's smaller, there is an air quality aspect, which is a big consideration when we think about transitioning to sustainable mobility. When it comes to EU has set several strategic priority areas to reach these climate neutrality targets. And to highlight a few, and of course the industry part is extremely important too, but because we are now looking at the city context, and as such, municipal representatives do not have so much control on what happens within the industries, even if they are based in the region. So it's a lot the national regulations that are determining how industries play a role. So when it comes to the things that municipal representatives can influence and which comes under that umbrella, there are a few strategic priority areas which are important. One is, of course, decarbonizing the energy supply, which means focusing on generating more renewables, maximizing the benefits from energy efficiency, of course, reducing the energy, the need for the energy is one of the best ways we can reach these targets. Then looking at clean and connected mobility and developing a smart network infrastructure. And so more towards smart grids, the distribution networks on how the energy produced in distributed areas could be used. And there are different ways that cities are looking towards implementing these priority areas within their cities. And one of those ways, and I wouldn't want to stick so much on the specific terminology, but one of the ways that cities are looking at it is through the concept of smart cities. This could be, the terminology used could be very different in terms of green city, livable city, future city, resilient city, and so on. But the goal really here, and this is our perspective from a BABLE's perspective of what smart city could be, and the definition varies a lot, but there are two important elements. One is using technology and data as enablers to support the energy transition. And the second is really that stakeholder collaboration, which a lot of you highlighted earlier, that is being used by cities in reaching this target. And smart cities, with the use of these, has a few promises. It helps when you use, and it's an important factor on how and when how you use the technology, but it really can help you make things more efficient, so processes more efficient, using less resources, definitely, it's Earth Day today, so definitely an important day to think about sustainability and more efficient use of resources. So something that smart cities can support with. We've worked with several cities across Europe, and one thing that has been highlighted is that while sustainability and the energy transition play an important role, cities also deal a lot with achieving their economic targets in terms of attracting business, having good employment ratios, and they have so much socioeconomic implications in a wider context. So making them more competitive is also one of the goals that cities try to achieve while having the sustainability and the energy transition goals that they have. And on the other hand, of course, having the more livable city, which is definitely a must for each city. And now that we think about smart cities, and definitely I think most of you have read about the concept also in news of late, with so much being discussed about it, it does seem like everyone is going towards it, everyone is implementing new technologies to reach these targets, but there are several challenges in the whole process. A lot of the times, and I know that innovative technologies wasn't highlighted even when now we had the poll wasn't highlighted as one of the key enablers as such, because a lot of that technology exists, maybe not in the urban context, but it does exist. The challenge is that cities bring in a social, cultural aspect in it. There's a different local conditions which make it challenging to implement that technology. So it's not that simple when it comes to, if something worked in, let's say, Barcelona, that the same thing could work in Stuttgart, where we are based, because the way people, interact, the way they live is very different. The socioeconomic conditions, the setup is very different, which makes it essential that when cities think about implementing these technologies, they are, and also in developing those policies, which was highlighted a lot in the poll today, they really do a trial and error concept. They understand what works for them or not. And that's why a lot of this work is now being started on a district level. So a lot of the Horizon 2020 programs, which have come up and which we will talk about, my colleague Gretel will introduce too very shortly. So the Smart Cities and Communities projects, they start at a district level. And the reason behind that is that, in a district, you could have, it's a smaller area, so it reduces slightly the complexity while still giving that real world conditions that we are looking at. And you could test with a certain group of citizens in a living lab sort of environment, certain technologies where, it's okay to fail, where you might learn from those mistakes and then take those into consideration while you're implementing smart city technologies. We have worked with several cities where we've tried to understand the challenges cities face in terms of having new policies which support implementation of these technologies. And when you look at it from their perspective, you understand that the diversity and complexity of the different elements in the city is it's so wide that it's really hard for them to introduce these policies which are new, which is not their traditional way of thinking, which are mostly cross-sectoral, affecting many different departments within the public sector body. It's quite challenging for them. And starting with the district level gives them that opportunity to test and to see what works. Also, different areas within a city have different needs. So sometimes, there's a district which is being completely built from ground up, a new greenfield development, where you could have more ambitious targets, where while building, you could make sure each building is energy positive. But that's not the case always. And that's why kickstarting on a district level really reduces complexity. It de-risks investment. So bringing in more investments for actually implementing those technologies gives invisible impact, reduces time for innovation. So also working with the SMEs to really get these technologies into market, increases the acceptance and makes the best use of resources. One of the methods which is being introduced which has been introduced by the EU somewhere around 2018 is the positive energy districts. And in the beginning, so somewhere around in the last few decades, EU had a huge focus on buildings and reducing the energy demand, so improving energy efficiency of buildings, making them positive, so having focus on local energy generation through the installation of solar panels, maybe using heat pumps and different kinds of technologies there that were being focused on specific buildings. And this led to also the formation of the Buildings Directive, which was launched recently. And now, as you know, that most of the buildings, so all new construction in EU from 2021 is expected to be nearly zero energy buildings. So there has been a lot of progress being done on an individual building level, especially in new build. But you do recognize that districts and neighborhoods are not just individual buildings. It's a combination of buildings with different purposes, with different kinds of characteristics, with different other additional requirements. You need people to move, you need people to have additional services which are beyond a building level. And that's where the concept of positive energy district comes, where a neighborhood, so the definition of what a district is could vary. So it's mainly a group of buildings, a neighborhood, an area within a city which is made energy efficient and energy flexible. So the goal is to have at least net zero greenhouse gas emissions and actively work towards having a surplus of renewable energy production from the district. That's sort of the idea of what an PED could be from the JPI Urban Europe, which is an EU set up body for working on these concepts. But there is so far, and we've been working with several cities on this topic, no concrete agreed definition for what a PED is. There is a reference framework which kind of provides the guideline for it. Apologies for the quality of the image here, but just to highlight a few things in it. Mainly the three defining elements of the framework, so which are essential when we think about positive energy districts. One is energy efficiency, which is reducing the energy demand, optimizing the energy demand within a district using the technologies that are out there to support reduction in energy efficiency, energy production, which refers to renewable energy production locally. And the third is energy flexibility. That's really managing the energy demand and the energy production effectively to enable having that surplus energy that is being produced and exported. And there are many different enablers for this, which includes the political vision, the active involvement of different stakeholders, integration of this on an energy and urban planning level, and of course, new technologies in terms of using ICT and data management. Now, going into the PEDs, as I mentioned, there's no specific definition and agreed definition. So there are three different elements, which factors which determine the scope of the PED. So when you're looking at a project which is talking about being a positive energy district, it's important to understand what these three factors are in that case of that project. And those are around the spatial boundary. So we're looking at what's the geography we are considering and where are we looking at when it comes to where the renewable energy production should be. Can it be imported? Can it not be? Energy sectors in terms of which particular sectors are being used, and also time steps. I'll come to it one by one. So looking at it from a spatial boundary perspective, there are three types of PEDs. One is a PED autonomous, where the energy system is constrained within a geographical area. So all the energy that's needed for by the district is being produced within the district. So all the solar PV may be using geothermal energy, maybe using wind energy. So all of that is being produced within the district. No imports allowed. The dynamic PED is where the energy is mostly being produced within the district, and on an yearly level, that all that energy is being produced within the district. But there are times when there is an exchange of energy with neighborhoods outside, so probably the region outside, or through the grid, that you are connected to the grid, and there are those momentary dips where you use the electricity from the grid. And PED virtual, where the energy system could be located outside the geographical boundary. And this is considering cases, where you do not have the right energy resources within the district to generate all of it. It might not make economic sense, for example, because it's not the best case for having that renewable energy production within the district. So you look at areas outside the geographical boundary to identify areas where there is renewable energy generation. To show this in a figure, this sort of shows the three districts within a city, and that's also the concept that you might not be able to have an autonomous PED. And here you can see the red lines are sort of the heat energy being transferred. The black lines indicate the electricity being transferred. And I won't explain the whole graphic, but just to highlight that when you look at the autonomous PED, you see that there is no energy going in. There's only energy, so that's electricity coming out. So it's self-sufficient at all times. So that's the PED autonomous. In PED dynamic, there is electricity and heat exchange happening, but in general, there is a lot of energy being produced within that particular boundary. And in PED virtual, there is a lot of the energy also being produced outside, but associated with the district, and that's being used regularly. So it really depends on the geographical conditions that the area has, that the city has, on the economic resources that are available. So I wouldn't say that one kind of PED is, it's important that you have an autonomous PED every time you think about PEDs. It's really about what makes the most sense in a particular circumstance. And there is a lot of debate going on which one of this makes, works the best and so on for different areas. But those are sort of the three classifications for what a PED could be in terms of the geographical boundary, and what you could include and what not in terms of where the energy is produced. Is it within the boundary, or is it okay to have energy being produced outside the boundary? A lot of the current PED projects are towards PED virtual. So there is energy produced also outside the district. So while they try to have as much energy being produced within the district as possible, there is the part of being relying on the outside world. So using, say, solar energy investments in nearby areas and so on is a common thing. Also because, cities and dense districts are also not the best places where you find the space for investing in all the renewable energy that you need. So there's also that space challenge where, and we were working with one of the cities where they did highlight that a lot, is, this challenge with, do you want more parks in the city, or do you want more solar panels being put up in the city, where there is this dilemma on how best to use the limited space that a region has. And that's why these different types of PEDs, and depending on where the energy is being produced, is definitely a question to be discussed for each district depending on its conditions. The second element then, when we think about PED and its definition, is about what energy sectors are being included in it. And there could be different that you consider, for example, electricity. So there are few main which are being considered in most cases. And then there are some which is kind of a question then on whether this is being considered or not. So for example, electricity, heating, cooling definitely are considered in most cases. Mobility is generally a challenge while considering in the PEDs, because you're then thinking, what mobility would you include? Is it the mobility within a district where, people are moving from one place to another within the district? But then what about cases where someone is going from within the district for work to outside the district? What about the carbon emissions and the energy being used in that process of movement from within the district to outside, or for people coming from outside into the district? So these are sort of questions where we talk about the territorial principle and the polluter pays principle on how is this being accounted for. And while there is a lot of debate going on this, we do not have, let's say, a standard way on this is exactly how a PED should be calculating these aspects. Another element which is not considered very often, but is an important aspect, is other energy uses, such as construction of a building, which is in the area. also causes a lot of energy. Or if you think about raw materials that are being used for different purposes, maybe the products that people use. So it's not the scope 1 and 2 of greenhouse gas emissions, but rather the scope 3 when you think about the framework for greenhouse gas emissions. It's about things that you use. So you might be using food, which is produced outside in rural areas, but the emissions at the end, is it the people who are using it, where they are using it, is it being paid there, or is it being considered outside? So that's sort of a question, and some of the areas where this is definitely a challenge. To give you just a highlight of some of these elements on where it, how the energy is, or the energy use is being distributed. Just an example from Leipzig, and I saw earlier that there's someone from Leipzig here too, just so great to see you there. This is from the Umsetzungsbericht of Leipzig in 2018, and it's in German, but I just wanted to highlight a few things from that figure, which is a very great figure giving an overview of where the energy is being used. You see that this is basically where the heat energy, and you can see it's the major share. So the size of these circles are also indicating the quantity of energy being used for the different applications. So there's a huge amount of heat energy being used, which a huge percentage, so 51% of it goes to private households, 47% to the industry, to the economic activities happening there, and 2% to the public sector owned buildings that are there. Then there is the electricity use, which is going into, again, a lot actually to industry, then to private households, and then to the public sector owned buildings. And finally, you have the mobility sector. And you can see that there are so many different energy sources that are being used in the whole process, and where each of it is feeding into, and a lot of it also coming, so the external storm we talk about, which is coming from the grid. So it's quite challenging, and this is on the city level. So on a district level, it's also quite challenging to do these calculations. So an important consideration when we are building PEDs is also looking at how we are calculating this, and what are the different energy sectors that we are considering, and the scope that we are considering in the process. And that takes me to the final element of the PED definition, which is based on the time steps. So the scope based on balancing time steps is an important area that I would like to highlight here. Now, when we are thinking about a traditional district where there is no renewable energy being produced at all the energy demand of the district in a year is supplied through energy import into the district in the year. When we talk about an yearly energy balance, and this is a choice which the PED developers are looking into, is that the energy demand of the PED, you're looking at it from a whole year. So at the end of the year, you would do this analysis where you look at, this was the energy demand of the PED. This is the energy generated in the PED. So that's the local renewable energy generated. And this is now the case for the virtual PED, right? So if it is a virtual PED, you would be importing energy into the PED, and minus the energy export from the PED, which is the energy that you're giving away when you have surplus energy production. And you want this to be equal to or greater than. So that's equal to is sort of the minimum to have the net, and then greater than to have the positive energy district. And here you're looking at on a whole year level. So it's not the instantaneous one as we were looking at the autonomous PED, but rather on a whole year level, the energy demand is being satisfied through the energy generated within the PED. And there is that balance in there. And then we look at the hourly energy balance, which is also a potential way for calculating, where you want to make sure that the PED is generating a surplus or enough energy to satisfy the needs and the demands of the district every hour within a year, which is also quite challenging depending on the seasonal variations and so on. So the hourly energy balance does not take the seasonal variations into account, whereas the yearly energy balance does take that into account, that there are some times when you are producing a lot more energy. So that's more representing the yearly energy balance, representing the dynamic PEDs as such, and this is representing more the autonomous PEDs as such. So just to give you an idea, and not to go too much into the actual equations, but to give you an idea of how the decisions of the senior executives when it comes to developing a PED, and could be municipal representatives. PEDs could be developed as private sector developments too, but these kinds of policy decisions can have a huge influence on what we call a positive energy district, and what's the actual result that we get out of the positive energy district. And it could also be stepping stones, so you don't have to achieve that final version of, having that hourly energy balance right away. And probably in some areas, you could not achieve it just because of the kind of energy resources that are available there. But there could be some areas where there could be stepping stones where you're moving towards net energy, in the sense of, having net zero carbon, where you're managing all the energy demand through local generation over a year. And in some cases where you are going beyond that in periods where you might be doing that every hour, which is quite ambitious actually. And now that we've looked a lot into what is a PED, and the different ways you can characterize a PED, because it does not have that standard definition. So it really depends, and I think those are the reason why I showed you those different factors influencing the scope of the PED, is also to have those questions when you look at PEDs next time, to think about what exactly is the boundary, what are the time steps they are looking at, what are the energy sectors that they are considering while defining that particular PED. Now, going a bit towards the more practical aspects of it, we also want to see at what kind of constitutes a PED, because while this is a very ambitious and also good sounding goal to set, that you want to have a positive energy district, how are you actually going to achieve it? What kind of implementations do you need to achieve it? And we're looking at some smart energy solutions. And first, I would like to show you an overview of some technologies that would play an important role in having this kind of an integrated urban energy system in developing a PED. And some of the technologies here include, of course, when it comes to buildings, of course, energy efficient buildings is an important area, but then local renewable energy generation, energy storage, demand side management, an important area, having smart grids, leveraging on the fact that there is industry, there are different needs, and building on that, having electric vehicles, so covering that mobility aspect with electric vehicles or any other kinds of, so there's a lot of discussion happening on biofueled powered vehicles, or on hydrogen, which is coming up, maybe for more different kinds of transport, long distance and so on, but different kinds of energy sources for that. Then looking at demand side management on an industry level, having that smart energy networks and the district heating and cooling networks, which is being looked into, and again, energy storage and so on. So renewable energy generation, of course, being an important piece of the puzzle. So those are some of the technologies. And while as most of you also highlighted in the survey that we did earlier, it's not that the technology is as such a barrier, because a lot of research has been done in these technologies. It's about how do you implement these technologies in a city, in a district. How do you bring this into the complex real world that we live in, and the agreements that we have, the economic setup that we have? How do you manage these things? Because the energy industry is a legacy industry. A lot of the technology that is there, a lot of the way it's a very hierarchical industry in the way it operates, and several of these are disruptive technologies. So the supporting policies you indicate are essential, and a lot of cities are now working on many different levels with companies to identify what could be the enabling policies, what could be the frameworks in place to really implement these technologies and make them possible. So that's giving you an overview, and I thought it would be interesting to give you some examples of use cases that we have on the BABLE platform too. So the company we have a platform that has a selection of best practices, and my colleagues will talk a lot more about it, but I wanted to show you some implementations that have happened, and these are a lot on the focus of what I am showing you right now is on energy in existing buildings. So I do see that as one of the biggest challenges that we have to tackle, that while new buildings are being constructed in a very energy efficient way, it's the existing buildings that need to be retrofitted that is one of the biggest challenges EU faces also in this transition to be net. So just a few examples to go through then on that. And a lot of these are from a few years ago. So they are from the Stockholm, from the Grow Smarter projects, one of the Horizon 2020 project again. And I'm showing those because they actually have some results associated with it. So it's quite interesting to see the figures in there. So the first one here is in Stockholm in Valator. And here what they did is they had social housing. They selected 6 social housing buildings, and they did deep energy retrofitting in these buildings. So here they implemented many different technologies there. So they upgraded the thermal envelope. They did when it comes to the heating systems, they upgraded it to district heating networks using a combination of then geothermal heat pumps with it, exhaust air heat pumps with it. They did implement renewable energy generation. So there was PV panels there. They also recovered energy from wastewater, and they also implemented smart building management systems. So it was a deep energy retrofit. They actually moved the tenants from the buildings outside when a lot of this work was happening, and then implemented these technologies, and then the tenants moved in. There was training being done to support the tenants in understanding how to use this technology and so on, and how to have a more energy efficient behavior. And they had amazing results. They had 78% savings in heat and 70% average energy savings, so including electricity and heat within the buildings. That's amazing success that they had, where they really monitored the energy use for a couple of years after the implementation and after everyone moved in, and they achieved these targets. In the same project, they had a more recent building. So the social housing was quite old, somewhere around 1960s, I think. But this was a more recent building, I think somewhere around in the, I think it was 2010 or so, and where it was, so the building was already energy, so it was quite efficient with good insulation and so on. And what they tried to do here was to more look into the smart elements of it. So they looked at having adaptive control for heating, indoor temperature meters, so that there is it's actually looking at the temperature, and the heating system is so more a centralized control for it. Then smart ventilation, where the windows are opening and closing, the air exchange is happening automatically, water saving equipment. So, they did have some kind of renewable energy storage generation too, but a lot of smart elements. And through these elements, they could achieve 11% saving on heating and 19% on electricity. So this wasn't deep energy retrofitting. So they didn't break down the walls and so on, or added anything on the walls. It was more the smart equipments that were added, and they could get substantial savings from it. And the third one to compare, and I chose these 3 specifically just to compare also, the different kinds of implement installations that they have done. This is from Barcelona. It was from the same project, and here they did not implement any energy retrofit measures or even smart technology as such, other than smart meters. So they implemented smart meters, and it was a group of volunteering. So several homes volunteered to be part of this, and they got insights on an app on how best they could reduce their energy bills. So they got ideas and insights on, hey, do this at this time. It wasn't automatically happening. It was more focused towards influencing user behavior. The project was aiming to have 10% electricity savings. And in this particular case, they were so amazed to get 15% savings just through change in user behavior by having that informed decision making based on the information. To give you that comparison between having that deep energy retrofit, focusing on smart elements, and then focusing on user behavior, all 3 very key elements of making existing buildings energy efficient and potentially energy positive too. So just some ideas. Of course, there are many different use cases we could go into in terms of smart grids and so on too, which you could find on the BABLE platform. There's just three useful and interesting ones that I found interesting. And while the technology does exist, when it comes to positive energy districts, there are 4 important factors determining success. And I think you guys highlighted this very well in the survey that we did in the beginning. So one is political support. So also, because a lot, and when you work with cities, you really identify this, that a lot of the things are not within their control. They work on national level frameworks when it comes to energy rules and regulations, several times on an EU level. So having that political support is quite important. And I think we will see this in the future, as also now the EU climate law came into action, that this is going to get stronger and stronger, and we will have more push towards transitioning to these technologies. The second part is having agile and integrated governance model, and this ties in well with having those supporting policies. So having that possibility where different departments within the public sector can interact with each other and come up with new policies, come up with testing, are open to testing new policies and so on. Also are open to working with different stakeholders, which brings me to that third point, which is co-creation with citizens. And I would mention also with stakeholders, with energy companies or researchers, as most of you here are, to really work with them to understand how the technology works very well and then implementing it. But having that exchange, because I think that information is missing, where the companies also understand the challenges that cities face when wanting to implement such technologies and could consider that in their own design process. And the final one being financing models, of course, because while there is a lot of financial support existing for this transition, so there are the EU Green Deal also has a huge focus on this, and several of the national governments also have green recovery plans with a huge focus on having a greener transition, having smarter financing models to leverage on these funds, but also then upscaling and really looking at solutions beyond the funding models, and having that economic case in the energy transition is an important area where there is a lot of research going on, but does need a lot more work on it too. So there was a recent research which indicated that cities could cut their carbon emissions by 90% by 2050 using technically feasible mitigation measures. So the technology there exists, but it's the collaboration from different industries, from research organizations, national governments, and citizens that's needed, so that we can really achieve this and build those factors which we highlighted earlier on, the enabling factors that can really make this possible and make this real. So it's really about this collaboration. So definitely inviting all of you to reach out to your local authorities or look out for programs where we can really work on this together and foster that collaboration to reach this very ambitious targets that we've set for ourselves. And that was it from my side. Thanks a lot, guys. And I'm sorry that it was a huge discussion from my end. So I hope you have questions.